Hello, good morning, good afternoon, or good evening, wherever you are. Welcome to our webinar, Design and Simulation of Systems with Hybrid Solar Panels, PVT. Today we have 1 hour to understand how you can simulate PVT panels with the simulation software Polysun. And immediately I also want to present our panelists. My name is Andreas Wolf, and I'm very happy to welcome Mirko Köhler from the company Sunmax PVT. He's a business development manager there, and he will present his company and his products by himself in a moment. Then my colleague Hanna Gäbelein, she is head of services and consulting of our company Vela Solaris, and I will briefly present our company, and then she will talk later about Polysun and show you how you can simulate PVT panels with Polysun. This webinar will be recorded, and you will receive automatically tomorrow, 24 hours after the end of this webinar, you will receive an automatic email with a link where you can watch the webinar again. So in case you have some questions after you have watched it again, that's no problem. Of course, you can contact us anytime and ask those questions. If you have any questions today during the webinar, you can also write them in the question section. You should see them on the on your control panel. So there's already one question asking where you should post the questions, and it's the question section, not the chat section. So please write your questions in the question section, and we will look after them at the end of the webinar. So as I have already mentioned, when we will do that, I want to present to you the schedule. So after a short presentation and introduction, we will then listen to Mirko Köhler, who will explain to us the hybrid solar panels, the technology, and show us also some very interesting examples of installations. After that, we will listen to Hanna Gäbelein, who will show us how you can simulate hybrid solar panels with Polysun. And then, as I said, after that, we have an open round with question and answers. So I really invite you also to post some questions which pop up right now. So just, yeah, don't hesitate. We are here for you. And the purpose, of course, of this webinar is that you get an idea about PVT panels, about Polysun, and how you can combine them. So in case you have never heard of Polysun and our company Vela Solaris, so who are we? Vela Solaris is a leading company for simulations of energy systems. We are based in Winterthur in the canton of Zurich in Switzerland. And the first software developments have already taken place in the 70s, and the brand Polysun simulation software is available since 1992. Our company, Vela Solaris, is a spin-off of the Institute for Solar Technology of the University for Applied Sciences, Rapperswil, also in Switzerland. Today, this is the University for Applied Sciences of Eastern Switzerland. Polysun is worldwide used, worldwide distributed. We have active users in more than 40 countries, and even more not so active users in other countries. So it's really used worldwide, and it is available in 12 languages. Today, of course, our webinar is in English, but if you prefer French or Spanish or Italian or Chinese, that's no problem. You can use our software in those languages as well. And you get always a multilingual software license, so you can switch from one language to the other in any moment. And what makes Polysun particularly interesting is that all building integrated energy technologies can be simulated. You can combine thermal and electrical components, not only within the same software, but within one project. And that is, of course, what will be also our topic today, because obviously hybrid solar panels are hybrid. They are combining thermal and electrical components, not within one system, but within one product even. And so Polysan is particularly suitable to combine thermal and electrical components. We don't only sell the software and then leave you by yourself. We also support you. We offer training courses. We offer consulting in the field of energy system simulations. So in case you require any assistance for any type of project, then please contact us. Even if you don't have Polysan, that's no problem. So here you get the first idea how Polysan templates look like. Of course, you will see this better than with Hanna Gäbelein, but already here you have the first idea. And indeed, this is PVT. That's our topic today. So you see here a PVT collector or hybrid solar panel, and that is connected to a system here together with heat pump and a ground source loop, even electromobility and electric vehicle, and all that for a building with floor heating and domestic hot water demand, and of course also the energy, the electric energy which is consumed in the household is simulated. So I have already mentioned that you can combine this. This is just an example. Our software contains more than 1,000 ready-made templates, so it's really enormous, and you can easily compare different layouts and optimize your systems. Also, we have numerous result outputs, tables, and graphs from annual overviews to single simulation time step values. It's a very transparent software, and you can analyze your results very much in detail. So in case you still haven't tried out the software, you can download the trial version from our website. It's velasolaris.com, or as I have mentioned, you can send us an email with your questions to info@velasolaris.com. So now I would like to pass on the word to Mirko Köhler, who will introduce us to Sunmax and to the technologies of hybrid solar panels. And well, I'm really looking forward to it, and I hope you too. And I'm really also looking forward to the questions which you have. Yes, so please, Mr. Mirko Köhler, I'm looking forward to your presentation, and the word is yours.
Yes, thank you very much for the nice introduction. Hello to the audience. I'm thankful that we have so much persons who are interested into this topic. My name is Mirko Köhler. I'm here for the company Sunmax. So we are the producer of PVT modules, so photovoltaic thermal modules. We can produce electricity and thermal energy from one module. Shortly about our company, we are founded in 21, so let's say a young company, but as you can see on the right side, our production, we are the first PVT producer who brought this module to the mass production. The reason for that is we combine mass production from the PV sector with some knowledge from the automotive sector. I will get to details a little bit later. So we are the first producer where you can get PVT modules that are also suitable not just for single family homes, so also for offices, industry buildings, or for even bigger projects. And as you can see, our production that is close to the city of Dresden. So we are a German product, and we are not producing in China or elsewhere. For our company, this is a logical fact. So the past belongs to the fossil fuels, the future belongs to the renewable energies. And we would say our PVT modules are the next step for the photovoltaic modules. So where we can see PV has an efficiency of 20%. And we can reach a total efficiency of over 80% with our PVT modules. So how this could be possible if we compare PV modules with our PVT modules on the right side. Here, the example with 1 megawatt peak, so round about 2,500 modules, so a little bit bigger project. So as we can see on the left side, PV has just an efficiency of 20% because we just produce electricity. But what happens to 80% of the solar radiation? That heats up the module, and that at least is a negative fact. So we lose efficiency with every degree raising inside of the module. On the other side, our hybrid modules, we have aluminum heat exchanger on the back side of our PV laminate. And through this heat exchanger, there runs a water glycol mixture. So, and with this fluid, we can extract the heat from the module. And as you can see here, a typical temperature area in summer. So we go inside of our module with round about 23 degrees. And we get out of the module with 30 degrees. So a huge difference to a normal solar thermal collector. We are not raising the temperature to high temperatures of 80, 90 degrees. We are staying in the lower area. And with that, we have some positive things. So the first one is we have 5 up to 10% more electrical gain compared to a normal PV. And we can use this low temperature not directly for the buffer tank, but we can use this thermal energy as a heat source for the brine heat pump. What makes us so special compared to other PVT producers worldwide? On the left side, you can see an electrical car, but there a few parts are missing, and you can see the accu, and you need to cool down the accu while you are driving or while you are loading your accu, and all electrical cars are using these aluminum plates as a heat exchanger. And this technology we transferred to the solar industry, and we combine it with the mass production of a normal PV producing factory. So, and if we can combine these two parts, we have the most powerful and the cheapest module worldwide at the moment. If we start how we include PVT into our buildings, and let's start with a simple version, with a single family home or with a smaller multi-family home. Our PVT modules on the roof, they deliver the electricity, so there is no difference between our PVT modules and a normal PV plant. The interesting part is what happens to the thermal energy. We go directly inside of a brine heat pump, and with the brine heat pump we can deliver domestic hot water and of course the space heating, because our modules are not just working in summer by solar radiation. Even in winter, if we do not have any solar radiation, we can work with the ambient heat. And for the brine heat pump, the heat source is relative. So even minus degrees are okay for the brine heat pump. And with that, in combination, we can provide heat all around the year for a single family home. If we take a look to massive projects in the industry or other project areas, so the electricity stays the same like in the single family home. Even with the thermal side, there is no difference. We can use the PVT plant on the roof as a direct source for the brine heat pump. But in these projects, we combine it most of the time so that we have a so-called bivalent system. We have a second source for the brine heat pump. In this case, it could be an earth probe or an earth collector or an ice tank, etc. And because we combine it, we have a positive effect in winter. So the brine heat pump can choose: do I choose the PVT plant on the roof as my source or the earth probe? And with that, we can reach very high efficiencies of the brine heat pump. And with that, of course, a very low electrical demand of the brine heat pump, and it is possible to scale up the PVT plant endless, let's say. And a bonus, what we can use the PVT for is the cooling. That means we can extract heat in summer from the buildings and give it to the roof inside of our PVT modules, and via the radiation to the sky and the cooling effect to the cooler air ambient, we can lose this heat and go with a lower temperature inside of our building. So we have the possibilities of passive cooling, or we can also use the heat pump, so in a reverse mode, to even for the active cooling of the building. So that means no air condition is needed, and that is at least like a bonus. So we are using the PVT most of the time for heating, but it is also possible to cool down the building, and we can use even this technology in winter to melt down the snow from the surface of the modules. What happens inside of an geothermal earth probe if we regenerate it? So if you can see here on the left side, an earth probe field, or where we lose the heat of the earth all around the year. So because we extract more heat from the earth probe field than we can earn from the natural regeneration. But if we use PVT for the regeneration, we can extract in winter the heat from the earth, and we can give back the heat that we gain on the roof via our PVT modules and give it back to the earth probes. And with that, we can use the earth probe field endless. A few words to our modules. So our dimensions are standard in PV area. So we just have an area of 2 square meters, and we just have a weight of 29 kilos. So we are very lightweighted, just 7 kilo more than a comparable PV module. At the moment, we have a PV power of 430 watt. Peak, so that means like a standard PV module at the moment. Not to forget, we have the cooling gain, because we cool down the module of 5 up to 10% of the PV gain. And we have a thermal power of 1200 watt. That means 60% of the solar radiation is transformed into heat. The second value, 1522 watt, that is if we do not use the PVT module for electrical gain, so nothing you would do in reality, but you can use this value to compare our module to a normal solar thermal collector or with other PVT modules. So that is, I guess, for most of you, the interesting part of the PVT module, not the front side. This is the back side. This is the aluminum heat exchanger from the automotive sector. So as you can see, the small channels, that is the way where our fluid goes through. And we have 2 adapters on the back side. So, and with these connection hoses that you can see in the middle, it is possible to combine our module to a normal pipe system, and with that the hydraulic system is very easy to build up. So there is not a very difference in the mounting system to a normal PV or solar thermal collector field as you know it. As we can see it here, that is a standard construction for a flat roof, so east-west construction. But we also can use our PVT modules, of course, on a pitched roof or even in a free field. The only difference to a normal PV construction is the pipe system. So we need a cold and a warm pipe to connect our PVT modules with the earth pop field or directly with the brine heat pump. And every module is parallel connected to these pipes via our flexible hose. And as you can see here on the pictures, we can use different pipe systems, so metal or even a plastic pipe system that is usable. So, and at least every installation company or planning company knows these hydraulic pipe systems. If we take a look to a real project in the mounting system, so as you can see here on the left side, so it's a flat roof. So we have an east-west construction. The pipe system is prepared, and at least there is no difference like compared to a PV system. We have two persons. One is holding the module, and the other person is doing the electrical and the hydraulic connections. And that's all in the mounting. And the same on the pitch roof. Here in this project, that was very interesting because here we had some PV modules before on the roof. So there was at least a very intelligent repowering in this project because we exchanged the PV with our PVT modules and are now very efficient on the roof, and the PVT modules are the heat source for the whole building. Now to take a look to our reference buildings, in which market segments we can use our PVT. Yeah, let's say everywhere. Commercial industrial buildings, district heating, of course, where we can use our modules even in a free field plant, or of course residential single family homes, multi-family homes. Everything is possible with PVT, and we start with a very small project so that you can imagine how this could work. So as we see, we have the PVT modules on the roof. In the cellar, we have the brine heat pump and the buffer tank. We have here 22 modules. That is enough to provide enough heat source for the space heating and the domestic water in summer and winter. And to bring you along with Polysun, that would be the system, how it looks like inside of the software. We see the PVT modules. We have here a source buffer tank that is between the PVT modules and the heat pump. And this is very useful because in the time where we do not need heat inside of the building, the source buffer tank can extract the heat from the PVT modules. And on the other side of the heat pump, there is everything like you know it. Even from the fossil fuels, we can use the buffer tank. We have the space heating system and of course the domestic hot water. Even in single family homes, we can combine PVT with earth collectors, like you can see it here on the roof. So there we have just 20 modules on the roof combined with an earth collector field. And even here, if we take a look to the schematic system, so we have the PVT modules, we have the earth collector, and now we have the chance with the intelligent heat pump that the heat pump can use the PVT module as a source, or it can switch to the earth collector, or we can combine both sources. Maybe in summer when our PVT modules reach a temperature that is too high for the heat pump, we can mix up the fluids from the earth collector and cool down it for the heat pump. And we can even use the PVT modules to regenerate the earth collector. Now we go to the biggest PVT project in Germany. We have here an industry plant with 1.9 gigawatt hours heat demand, and there we use 1000 modules of our PVT, combine it with the earth probe field, and with that we can solve the heat demand of the building to 80%. And we have an amortization time even in such big projects of 7 up to 9 years, and we have levelized cost of heat from 6 up to 8 cents per kilowatt hour. And very interesting, so the first idea was just to use an earth probe field. There we would have costs of 10 million euro because we used PVT, and we could reduce the earth probe field by 75%. Now we are for costs for the whole project of 2.3 million euros. So we saved 75% of the costs. And also here we take a look, so how we can combine it, like the schematic system with the single family home. We can combine both sources via a source management. So we can use the PVT, we can use the earth probe field, or we can combine it and we can regenerate the earth probe field. At least 3 simple projects. That is the biggest project in Europe with 1134 PVT modules. Also here in combination with a ground loop field. And there we also can regenerate, of course, the geothermal probes, and we can use the PVT. And with that, 1.4 gigawatt hours of heat demand are fully, we can hit the heat demand of this building, and we do not need any other source, no fossil fuels anymore on this sport arena. Even for district heating, that is useful. As you can see here, this is a low temperature district heating system we are using here. PVT on 3 different roofs in combination, like I said before, with an earth probe field, and with that we can also here deliver the heat from the roof to different buildings everywhere in this district. And the last example is a multi-family home in Berlin, in the capital of Germany. So we have a very complex roof. As you can see, even here is PVT possible. And let's say an air heat pump was forbidden in this area just because of the noise. So we can say PVT is the silent heat source for the brine heat pump. And why you should use modules of Sunmax? So we are the most powerful module on the market, and we have the highest production capacity. So we can produce 120,000 modules per year. So delivery, even for big projects, is not the topic for us. And the last slide is just a comparison of my speech. So you will get these slides afterwards, so that you can go through it if you have the time. And that's the end. And now, we hand over to Ms. Gäbelein.
Yeah, thank you very much, Mr. Mirko Köhler. That was very interesting. I think we really got insights which we can only get from a manufacturer. So that was really nice, and I'm looking forward to your questions. But before that, we want to see how can we use Polysun to design hybrid solar panel systems. And I'm looking forward to the speech of Hannah. So please, it's your turn.
Yeah, thank you very much, both of you, and thank you all for being here today. So I'm very enthusiastic about the topic of hybrid solar panels, or PVT, because it's something that I'm confronted with in almost all of the projects that we do for our customers or for our users of Polysun, where we support them with their own projects or train them how to use Polysun for their individual energy system plannings. And so, yeah, it's very nice that I can give you a short insight today in how to use Polysun to do so. As you can imagine, this is not an easy task. So we have a lot of components in this energy system, and they all interact with each other and they influence each other. So it's no way around using simulation software tools to design these systems properly. And I will take you into the Polysun software, and I hope you can see my screen already. Please don't worry if this is a bit of a deep dive for you. If you never saw Polysun before, my colleagues Andreas and Michael will surely show you the details if you are more interested in getting to know Polysun. But first of all, you have to know that this is how energy systems look like in Polysun. And as already mentioned, we have around 1,000 system templates ready to use for you. So there's no need for you to learn all the details from the beginning. You can really start working with it in an easy way. And the most important thing you need to do, especially when planning PVT systems, is that you set the right location for your system. And you can do that very easy. Here you can see that today I chose Zurich as our location because it's very close to where Villa Solaris is located, but it can be any location around the world. And you can really also zoom into the street or the roof that you want to plan. So that gives you a high accuracy for the weather data, for the outdoor temperature data, but also for the global the irradiation data and the horizon, which is especially important if you plan a system in a hilly area, or if you have mountains around, or other objects like huge buildings that can throw shadows on your plant. So that's important to start off with the location, but then we really go into the details here. And I brought you some examples that are not exactly the ones that Mr. Köhler showed us, but the principle is the same. And the first example you can see here is the so-called two-soul system. The Alliance two-soul is quite well known in Europe, I guess. And I think it's great work that they do, which you can see in this system template here, because it combines the benefits of all technologies that are available in the system. And for this example, I'm designing a system for a multi-family household that needs, of course, heating, space heating, and domestic hot water on a temperature level of 60 degrees Celsius. And the nice thing about it is that this work has been done for us, and all the Polysun users that download the software can use this template and don't have to worry about control. So all you need to do is parameterize the systems. It's also included in the free test version that you can download on our homepage. Yeah, as you can see, it also links what Mr. Köhler mentioned before. So the direct use of the heat that we get from the PVT is not in the focus in this system, but we combine it with a brine to water heat pump and with the earth collector, just as a rough example. And this is really the huge strength of PVT panels, and you will see it in the results later on. So we can use the PVT here as a source for the heat pump in the winter time or in spring and autumn, to also increase the inlet temperature for the heat pump. And in the times where we don't need heat from the heat pump, where the heat pump is not operated, we can bring this almost any temperature down into the ground and store it for later use. So that's something very nice about this system. And it gives us a very good solar thermal yield, and it will also lead to a better PV, so electricity yield, because we constantly cool these systems. So here we have two orientations. It's an east-west orientation on a flat roof, but you can imagine that this is very modular. So you can, if you have a larger roof or multiple orientations, as on the last picture we saw in the prior presentation, then you can easily add more loops and add these orientations or other tilt angles, no problem. Basically what you need to know, like in reality, also in Polysun, you have to consider both the electrical part and the thermal part of the design. So let's have a look into the PVT collector component. Polysun comes with a huge database of manufacturer components. And you can see here that for this example, I used the actual Sunmax PVT collector that you can also buy later on and build your house on. So also we have some anonymous components if you want to simulate it without defining a manufacturer first, but this database is quite huge. So the first step would always be to decide on a collector, on a module itself. And then you can say, I know already how many modules I can fit on my roof. Or if you don't know, you can also use the total gross area that you have available and let Polysun calculate the number of modules according to that. Both is possible, and it gives you the actual amount of modules for one orientation and one tilt angle. That would be the next parameters you have to set. So the orientation where 90 is east, 0 is south, and minus 90 would be west. And of course the tilt angle of the mounting system. So that's the easy part. And if we have more than one PVT component, like we have here, we would do it for both. And after that, you also have to design the inverter. So never forget about that this PV part also needs an inverter, and you need to design it. And Polysun helps you with this. If you're not familiar, or if you just want to have a very quick design, then you find a wizard here, which you can use to find a suitable inverter. So always make sure you don't miss out on that point. I've done it before, so I will not go through it now, but you can see it in your test version, I'm very sure. So if we are done with the electrical part, and this also includes the public grid, which is European standard, I would say here, also with the 50 Hertz frequency, but it can be adapted also to other countries like the US, where we have a 60 Hertz frequency in the public grid, and you will also find inverters that suit to that. Having done that, we need to also consider the hydraulics. So we need a piping system, first of all, that connects our PVT modules to the actual system that we want to supply. That is what happens here. And you can imagine that this is a simplification, but it works very well for the simulation. And also we need pumps here and here that transport the heat from the PVT modules to our system. And these pumps, they also need controls. So here and here we have a solar loop controller, and these controllers can be anything between very easy and functional up to highly sophisticated EMS functions. we have standard controllers that are so easy to use. You just need to click through it. But we also have a free programmable controller where you can insert almost any logic that you also want to try out in your real plant later on. And it always depends on where you want to go to with your system or which questions you want to answer with the simulation tool. But I think the nice part is that you can also do it on a very high level and easy and still get valid results. Let's have a quick look into one of these standard solar loop controllers. You can see that we have some controller inputs, which are usually the sensors in my system. I measure the outflow temperature of the east field collector. I measure the temperature in the pipe on the secondary side of my heat exchanger. And then I can provide some settings like cut-in differential, a cut-off differential, and then I have to define the flow rate for this solar loop. And we know that the specific flow rate is compared to traditional solar thermal plants, it is rather high. Can be even higher than 45, what I use here. It can go up to 80 or even 100 liters per hour in square meter. But if you don't want to use this setting, there's a lot more that you can use to find the right control strategy and increase the solar thermal yield. Okay, so let's have a look in how this system behaves. Polysun has a lot of results, basically. We have annual results, we have monthly or hourly results, but the very nice thing in getting to know technologies like PVT modules is that you can also use this simulation analysis that I'm showing right now to really scroll through your system to the entire year and find out how the system reacts. And I will zoom in a little bit because the numbers are very small, I guess. So you can't see the entire system, it doesn't matter. And don't be confused about all the numbers that you see here. You will learn very easy how to focus on which numbers are relevant for you and which not. What I want to show you here is all the benefits that we have from a combination of PVT modules with a ground source loop and a brine to water heat pump. So this is March the 2nd, around midday, and you can see that we get quite good temperatures here. Let me scroll a bit earlier. This may be even better. So what we are looking for here is to go through every time step that is calculated, which is sometimes a bit hard to find the right spot. Okay. Anyways, here we see that the heat pump is operating and bringing heat to the heating system buffer tank, and it is only supplied by the ground source loop at the moment, which is because at this time, evening 1st March, we don't have enough high temperatures on the PVT to use it. So it's a very flexible system. And maybe if we go a little bit earlier this day, we can see that it changes. So already in March in Zurich, we can yield some 10 degrees here, which are beneficial for my heat pump because I can mix it with the rather low temperatures that I'm getting from a ground source loop at the end of the heating period in Europe. So if the heat pump operates, then the COP will be much better than if we only use the earth collector at this time of the year. And this is one of the cooperation modi, but if we go into summer, which is also very interesting, And earlier I saw a question about how high the temperatures of a PVT could be in summer. And we will see it here based on the location that we chose in the beginning. So let me find the 18th of July. Somewhere around here, doesn't matter the exact date, but you can see here July 21st. Now it's already evening, but still we have some high temperatures. And of course, quite naturally in summer, we don't need so much more heat only for the domestic hot water and not so much for the heating system. So there's a lot of excess energy. And the synergy effect here is that we can store all this yield in the ground and we can put numbers on it actually using Polysun. So we know how much solar thermal energy can be stored in the ground and use it in the winter time. So you can really determine all the temperatures that you actually have. And of course, they are quite variable also on the irradiation on the weather data, but on the tilt angle, on the orientation, of course, and the flow rate that you apply for your system. And that helps you also to show how much the PV, so the electrical part, can benefit from these constant cooling, actually, that we do here. And you can use the system comparison, which is a function of Polysun, to compare a system where you have only PV and your ground source loop heat pump and compare it to a PVT system, and you will see the better efficiency of these modules. Good. So that would be a very first and rather easy system for a multifamily house. And now I would like to take you into a more detailed system, which is a low temperature district heating system. Also something we heard in the examples of Mr. Köhler earlier. And also here we combine a PVT collector field, and it can be huge, to a ground source loop. And basically any kind of district heating systems that you can imagine can be simulated with Polysun. But the level of complexity and the synergy effects that are also beneficial for the dimensioning of all the components make it especially useful for the 4th and 5th generation district heating, which also includes district cooling more and more, also in Central Europe. So, of course, you can also include all kinds of cooling, active and passive, that we learned today earlier, but I neglected it for this example due to the time. It's a bit more complex than to show. If you're interested in that, don't hesitate to ask us afterwards. So, generally, you can simulate the district you want to supply with energy on any level of detail. It can be very high level, especially if you have a purely residential district that you want to supply, then all the loads are comparable. And you can break it down to just using like the upper part here as a consumer hydraulic. But if you want to show a multi-use district as we have it here with residential homes, but also retail or offices or even industry buildings in it, then you want to also display them individually because the loads can change. And this affects the entire system very much. But you can see, basically, this is nothing else than just combination of all individual houses. And now I will zoom into this and have a focus on the office buildings that we have down here. So you can see that we can also take into account all the specialities that this district heating might need. It can be a single heat pump, decentralized, that supplies these retail buildings with a combined storage, because we have a few need for this domestic hot water, but a lot of space heating, for instance. And then we see this maybe old-fashioned office buildings, and they still need a high temperature. That's why we still have a boiler in here, which is a gas boiler here, but it can be kind of any kind of fossil or biomass fuel. And the controls here and here allow me to also align these two heat generators together so that they can supply this building and still guarantee that we have a good system COP, so the efficiency of the entire system should be good. And you can determine it either on the individual building level, or if we zoom out again, then of course you can make the whole balance for the entire system, and that of course includes the beneficial effects here of the PVT system, which is maybe shared on several roofs of this urban area. So it doesn't have to be one field connected. Maybe it just has one orientation. But as I said before, you can add multiple components and change the angle or the orientation and just attach them as I did here. And then we have this ground source loop that is both the source for the heat pumps if they need it, and it is constantly regenerated whenever we don't need it. And in this low temperature or exergy networks, district heating networks, my observation is that the PVT thermal energy can really play a huge role, and really you can make use of all the good effects that you have, because the temperature level is rather low. And we can see it also in the result overview of the system. If we have a look at the solar thermal yield, I mean, I didn't tell you how many modules are installed here. It doesn't matter anyways, but at least from the ratio of the photovoltaics, the line below, and the solar thermal yield, you can tell that this is a very good design and a very good use of the PVT. And it will for sure not only decrease the CO2 emissions or increase the efficiency of the heat pumps, but it will also give you the chance to design the ground source loop on all the probes better, and even save money, because you don't need so many meters, or maybe you can save some boreholes at all. And Polysun helps you to answer these questions. So whatever it is, be it on the demand side or on the generation side, there are approaches to it, and there's also a lot of knowledge about these energy systems in the company of Villa Solaris, where we are very happy to help you to get good results and reliable results, also in the very early stage of your project, probably. So I think at this time I need to stop and give the word to Andreas if there are any questions, but also if some questions arise afterwards, or if you find that I should go more into detail at some point, don't hesitate to contact us. Thank you very much.
Yeah, thank you very much, Hannah, for this interesting presentation. And indeed, we have heaps of questions. So now we will go through them. For privacy reasons, I won't mention your names. I will only mention the question. So then I hope you know that it was your question. You still recall your question if you maybe posted it half an hour ago. And in any case, if the answers were not complete, then just send us an email. The first question I will answer directly was regarding actually Polysun and which Polysun version is required to do these simulations. and which version you would download if you want to use the trial version. Well, you always download from our website the newest version. We only have one version on the website, so you really can't do anything wrong. Just go onto our website and in the section downloads, it's in the top line you have support, and then under support you will find downloads. And there you can download the current version, which is, as you can see here also on the screen, Polysun 2025.3. There are regular updates, so there will be another update in April, and yeah, and you will always get the newest version. And of course, when you purchase a license, you have also regular updates, and you will always have the newest version. So then there was one question concerning central heating in the Netherlands is 108%. Maybe if you can reformulate this question, because I'm not quite sure what is meant exactly or what you want to know. And one question was regarding the temperatures. Hannah, you mentioned this also, and you showed it also in the simulation. So, and that, of course, I would ask anyway again. So, what would be typical temperatures you could expect with PVT in summer?
Yeah, I guess that's more a question for me. So in summer, a normal temperature we reach is around about 30 degrees. Of course, it's also very possible that with a very high radiation and on a hot summer day that we can reach 35 degrees. The highest temperature that we can reach anyway with our modules is 81 degrees in stagnation. So if we do not extract the heat, our module acts like a normal PV module there. So that is also a big bonus if we compare us with a solar thermal collector, where we can reach 160, 180 degrees. So that means we have not the problem of high pressure inside of our modules, even in stagnation. And also the glycol, what we are using in our fluid, because most of the fluids have problems with high temperatures, and even these topics we do not have in the PVT area.
Thank you very much. And as we were talking now about summer, the next question is concerning winter. So how do you do it in winter? Can the panels freeze?
Yeah, the panels can freeze. So from the P module itself, the temperature doesn't matter anyway, so it is tested down to minus 40 degrees, so nothing will happen with the module. But of course, if you extract the heat and we have minus 10, minus 15 degrees, of course, we have a light freezing area on the back side, even possible on the front side. But with modern brine heat pump components and with the suitable software, it is possible to go to reverse mode, and that as I mentioned, we can melt down snow. So the same way with ice on the modules, we can melt it down very fast, and then the module is ready to go again. And even for the brine heat pump, it doesn't matter if we deliver minus 10 degrees or if we deliver 25 degrees. Of course, the difference is the efficiency of the brine heat pump. But even with minus 10, minus 15 degrees, with the correct brine heat pump on your side, it's never a problem for the space heating or for the domestic hot water.
Thank you very much. Then there was one question more concerning the mounting. In case of snow load, would you use a quarter clamping?
So For the mounting system, there is no difference between a normal PV construction and our PVT. So we are using the standard clamps that you are also using for a PVT mounting system. So we have the aluminum frame, and there is a small difference to standard PV modules because our aluminum frame has a height of 40 millimeters. So we have even a more stable construction than a normal PV module. And on the back side, also that is a bonus if we are talking about wind or snow loads. We have our aluminum plate that brings also a little bit more stability to the module. So a snow load at least is not a problem for us and for the mounting system. And if we have too high snow loads, we can melt down the snow.
Okay, thank you very much. Then there was one question concerning the slides. You will anyway get, as I have mentioned, the link to watch the recording again, so all of you can watch it anytime again. And then also we will send the slides of SunMax to the participants. Mr. Köhler, that is correct, right?
Yeah. That is correct. Everyone can get the slides.
Okay. Then there was a question concerning the Polysun templates. If there is a monovalent PVT template in combination with a brine heat pump. Hannah, can you say anything about that?
Yeah, sure. Sorry, I couldn't bring all the possible combinations in this short period of time, but there are templates available that you can use as simple as that. You will find them in the software.
Okay. And yes, as I have already mentioned, we have more than 1,000 templates altogether. So, and we have certainly also dozens of templates only with PVT, and there's really a lot to see. And don't forget, with Polysun Design, you can create your own templates. There is no limit in that regard. Also, the template which you see right on your screen now, of course, is not a standard template that has been created through a project. So there are no limits. Don't worry about that. Any template can be created with Polysun. Then another question concerning the system design. Can also a PVT system be optimized for an off-grid installation in combination with a larger thermal storage?
I'm not sure who is supposed to answer this. Is it me?
Yeah. Well, it would be okay. Yes, it's a good question actually, Hannah, because we cannot be sure if this is concerning Polysun or in general. Well, then let's answer this question twice. Once concerning the reality, let's say, and once concerning the simulation. So, who wants to answer first?
Yeah, I can start. Okay. So in Polysun, it's easy. You can make an off-grid or like an island system right from this public grid, which I showed you earlier. So that's easy, and it will of course limit the yield of the PV if your demand or the battery storage system that you apply is not large enough. And same goes for the solar thermal yield that we have. That is also limited to the storage possibilities that you have, which is usually a low temperature storage, but it can be also a sensible buffer tank, for instance. So that is only limited by the storage capacity that you have, and it's very easy to simulate that.
Thank you very much. And in reality?
And in reality, let's say, so the goal is nothing less than off-grid system for the thermal side. Yeah, the goal is always to have 100% of the thermal demand that is solved by our PVT. On the electrical side, it's just like a normal PV plant. So, and the simulation by Polysun to create such a system, that's easy, like Ms. Gabeler said.
Okay, thank you very much. Then there was rather a complex question concerning the simulation. I would suggest that we reply to this question by email. What do you think, Hannah? The long question.
Yeah, I think.
Okay, so please, I'm sorry, as I said, I don't want to mention your name, but please be patient. We will get back to you after the webinar because it's a complex issue and we should get a little bit deeper into it. And then there was a question, I might reply to this directly, concerning the controllers. So if controllers are really required, yes, they are required, and for a very good reason, because that's like the brain of the system, and that's the way where you can optimize the system and where you can make it really different even with the same components. So we need the controllers, but don't worry too much about the controllers. As I said, we have 1,000 templates ready-made, and they're all with controllers. I mean, it's not that they are missing, they're already there. So it's one thing is you can look at them in a passive way that you just use them, and one is that you use them in an active way and you design them, you set them by yourself. So then, of course, these are different challenges. But both ways you can go. So just use them or do it by yourself as you like. But in any case, yes, there are controllers. Then there was a question concerning the time steps. I will also quickly reply to this one. The time step in Polysun is a variable time step between 1 second only and 12 minutes. So it depends upon the system, it depends upon the situation in the system, which has to be simulated. Sometimes we can afford longer time steps and still not do many errors if there is not much happening to the system. In the system, for example, at night, of course, the sun is not shining. Usually the consumers are sleeping, so there is not much happening in the system. You can do longer time steps, or certainly for the heating part in summer, you can do longer time steps. But then, of course, during the day, when you have a lot of heat exchange, then you need shorter time steps. So it's a variable time step simulation. Then we have, let me see, there was a question concerning the thermal energy storage. Is there any way to set an initial state of charge or a specific layer temperature for the thermal energy storage?
Okay, it sounds like we have a simulation expert in here. So Polysun always starts the simulation at the 1st of January. This is something you have to consider. And of course, we have an initiation temperature for all the components. And you can manipulate it, or you can not directly set it for sure, but you can pre-simulate the system. So you can start the simulation 1st of October, 1st of June in the previous year. So it will count down the days and simulate the system during this time, so that the thermal energy storage has a different temperature than if you start like on the 1st of January. And we really recommend that, especially if you want to design seasonal storages, like an ice storage, for instance.
Thank you very much. Should the volume flow in PVT modules be turbulent or laminar? That's also a question which could be reality or simulation.
In reality, we are talking with our measurements about turbulent.
Okay, very good. Thank you very much. Then well, we have here, I'm sorry, I'm just, if there is a solution using only the component from the heat pump manufacturer. So I'm not quite sure about this question. Maybe you can also, yeah, send us an email and explain a little better what you mean by that. Then another question is, can the SunMax system be combined with green hydrogen production? That's a very interesting one.
Yeah, definitely. We have very high electricity and thermal demand projects there. We are talking about these possibilities in the planning. Actually, it's not a real life project, but we are planning something like this. Let's say we can use, of course, the electricity that we produce to produce green hydrogen and to use it afterwards. So that's not the topic to combine projects like this. I mean, Ms. Gäbelein, there would be also the question, is that possible to show it in Polysun? But in real life, we are trying to bring this in our projects, yes.
Okay. And then what kind of seasonal storage capacity does a ground source loop offer?
Depends.
Yeah, in this case, the person is living in southern Spain, and they have a lot of sun in the winter, but it's still cold at night. So it might be like Sierra Nevada, I'm thinking now right now, but of course I don't know if it's true, but I'm just guessing. And yeah, as they live in the mountains. So yeah, a lot of sun, but low temperatures.
Yeah. So at least it really depends to the ground. Yeah, do I have sand or I have stone? So there is a huge difference of the ground that is usable for regeneration, and so that's why there is no easy answering of this. Yeah, and it also depends. Do I just need the earth probe for the night? Yeah, and the day is enough to regenerate it again, or do I use an earth probe field as a seasonal storage that I want to transfer heat from the summer to the winter? So that's also a huge difference. So that means if we have bigger projects, there's also always a test drilling, yeah, that we know how is the ground and how is the capacity, the thermal safe capacity of the ground. And with these values, I also can go to Polysun to simulate the grade of the regeneration and how many drilling meters are necessary inside of the project.
Yeah.
Okay, thank you very much.
Quickly add to that. It's a very good question that can be answered with Polysun. Basically, if, as Mr. Köhler said, you have at least an idea of how the ground is, and it's not just the stone or the earth itself, but it's also the water content of the ground that influences the energy flow. And this can all be considered in this component ground source loop in Polysun. And then you can find out, and it also depends on the use of the thermal heat and on the regeneration with the PVT. So there's a lot of complexity and degrees of freedom in here, which makes it hard to answer, but you can simulate it and find the answer then yourself.
Yes, and a very general question, and that's maybe also could be interesting for many of our participants. So what does generation of ground source loops mean in general? I mean, what do you regenerate? Hannah?
Yeah, okay, I'm sorry I didn't go into that detail. I really forgot to mention. So basically, what we know from the past, especially in Central Europe, is that we extract the environmental energy from the ground, like I can show in here. We extract it, and it's on a temperature level of maybe 10 degrees Celsius. And we bring it to the heat pump, and the heat pump brings it to another temperature level that we can use for our heat that we use in the building. But this way we only extract it, and of course there are energy flows in the ground that naturally regenerate it, especially if this is the only ground source loop around. But if your neighbors have a ground source loop as well, and we know that very well in dense cities or areas in Germany and Switzerland, and the ground will cool down over the time of 5 to 10 years or even more. So to make sure that the temperature level in the ground isn't going down and the efficiency of your heat pump is decreasing with time, you regenerate it, and the heat, the solar thermal heat that is created in the PVT can be brought to the ground and stored there. So, and this is like a seasonal system where you extract the heat in the winter and then you bring it back in the summer when you have excess thermal energy here. It's a very clever and easy system basically, and we know from a lot of areas in Germany that you're not even allowed to drill a borehole anymore if you can't guarantee the regeneration. So it's as far as that, at least in Germany.
Yeah. Well, thank you very much for this very good explanation. Thank you. Then a question to Mr. Köhler: can heat also be used? Can the heat also be used as a mechanical power source, let's say a Stirling engine?
Interesting question, definitely, but no. We stay in the low temperature area, and even if we really go down with the fluid speed inside of the modules, then we can reach higher temperatures. But even in summer, there is nothing more to get than maybe 40-45 degrees, and that's in not so many working hours in the year. Yeah, so it wouldn't be economical to use the module for the high temperature area. And we have in mind, so as higher is the temperature of the thermal side, as higher is the temperature of the PV side, and with that we would have decrease the lifetime of the PV cells. We would decrease the electrical gain. So that's not the way how to use the PVT modules. Yeah, so that's why in 99% of our projects, it's in combination with the brine heat pump. There is maybe one business case that is interesting. That is if you are using PVT for public pool systems. Yeah, there you could use the PVT without a brine heat pump to heat up the public pool. Yeah, there you do not need any more different components, but to use it for damp and other ideas, that's not the idea behind PVT.
Yeah, thank you very much. Very simple and short question: what's the lifetime of PVT?
So we have the Solar Key Mark certification from the Fraunhofer ISE, and they tested the module even with artificial aging, and the Fraunhofer ISE said with their certification the lifetime of our module is over 30 years.
Okay, thank you very much. Then there is also another rather long and complex question concerning the limits in the temperature. So also in this case, we will get back to you by email. Then does Sunmax also install hydrogen storage systems?
We do not install anything. We are
in hydrogen storage systems somehow, or could you help with anybody who is interested in it?
Yeah. So let's say it directly. We are the producer of the PVT modules, but of course for bigger projects, for industry, commercial buildings, public buildings, Of course, we can help by consulting for these projects, and we have a big network of planning companies, installation companies, where we could forward you with your projects, and there would be then at least the planning and the final consulting. But for your first ideas, of course, get in contact with Sunmax.
Yes, okay, very good. And also another short question, and then I think we have to come to an end. And for all the questions which might have been left out, yeah, we will get back to you by email, and you can contact us by email too. So what is the weight of a PV? No, in this case, the question is even concerning twice PV. So I'm not quite sure now if this there's a mistake in the writing, if it's PVT. But well, I now ask you: is there, how much weighs a PVT module compared to a PV module?
Yeah. So a standard module compared to our PVT module weighs 23 kilogram. And our module is 29 kilogram, so at least we have 7 kilos more of weight, that are 3.5 kilos per square meter.
Okay, very good. So yes, I'm sorry that we will now have to stop, because already it's really late, and I thank you very much for your patience. Just one very last question I will answer. It's concerning if we have training programs for solar photovoltaic and solar thermal design. Yes, we do, and of course it's this today it was all concerning PVT, but we can only do PVT if we understand solar thermal and PV, because obviously that's a combination, so it would be impossible otherwise. So of course we do also only solar thermal, we do also only PV, and of course we have training programs concerning all the three of them, concerning heat pumps, concerning ground source loops, concerning ice storage tanks, concerning cogeneration, and so on and so forth. So yeah, please contact us if you require any assistance or if we can be useful for you. Thank you very much to all of you for your very active participation. That was really lovely, and we will be in touch and get back to you concerning all open points. Thank you very much, Mr. Köhler, for your great presentation. Thank you very much, Hannah. It was really a pleasure to have you here today. Well, I wish you all a happy day, evening, wherever you are, because we have actually participants from all over the world. So yeah, thank you very much. See you. Bye-bye.
Bye.
Thank you. Bye.